Welcome to this special edition of Frequency Matters, the RF and Microwave Update Series. I'm Pat Hindle. I'm here with my co-host Gary LaRude, and we are joined today by Joel Levine, President and CEO of RFMW, the RF and Microwave Component Distribution Company. We're going to talk today with Joel and his team of RF power experts about the current state of the RF power market, which different active device technologies are winning in different applications, and also to get a prediction of the future market trends. Welcome back to the show, Joel.
Thanks for having us, Pat and Gary. It's always a pleasure to talk about my favorite subject, RF and microwave components. With me here on the call, we have three of RFMW's key RF power experts, members of our RFMW Dream Team. RFMW, as you know, focuses on getting the best and brightest RF talent that we can get for sales, marketing, and technical support. And with us today, just a few examples. We have Phil Knights, who with 29 years of experience worked at PowerWave, also worked at the original NXP, and then moved to Amplion. He joined RFMW in 2019 to support RF power business development. We also have Tim Daniels, who worked as an RF design engineer for 13 years on power amplifiers at power levels from 100 milliwatts to 6 kilowatts before joining RFMW as a field sales engineer in 2011, and who is now the leader of our RF power business. And we just recently hired Leonard Pelletier, who has been working in the high power RF industry for the past 33 years, with the majority of that time spent with Motorola, Freescale, or the new NXP, whichever name you want to give it, in application support. You may know him as RF Leonard. And of course, myself, I've been involved in the RF power market in one form or another for the last 46 years.
Great, thank you very much for the introductions, Joel. Let's start with what is the current state of the RF power market, given the latest advances in device technologies?
Let me take that one. So there have been many advances in the RF power device market recently, Pat. Here at RFMW, we make design recommendations based on the application's specification requirements, which can dictate the technology we offer to our customers. For example, in industrial applications at VHF and UHF frequencies, then LDMOS continues to evolve and is still very competitive device technology. The latest generation of high power, extremely rugged devices are specified at up to 2 kilowatts and 65:1 VSWR. So they make an excellent choice in those types of applications. But as the frequency reaches about a gigahertz or so, efficiency starts to become critical for specific applications. So take a multi-kilowatt particle accelerator, for example. Even a 1% gain in efficiency can make a huge difference in the electricity consumption when it's running continuously. So whilst GaN is the technology that immediately springs to mind for efficiency, and we've seen GaN devices being used at UHF, we also see each generation of LDMOS close this efficiency gap. When we get to the cellular bands up to 4 gigahertz, LDMOS has certainly not gone away. RF power mimics, multi-chip modules, complete with integrated DOT amplifiers and 30 dBs of gain, typically in a 10 by 6 millimeter package. These are now the norms. And 5G and massive MIMO are driving even further levels of integration. We are sharing some exciting roadmaps with our customers at the moment. GaN is starting to appear in cellular applications a little more now, and the latest generations are more cost-effective and easier to linearize. I think we must be getting closer to the LDMOS GaN tipping point. As you can appreciate, different device technologies have distinct advantages in different applications. With our experience and products from three of the top RF power vendors, Qorvo, Amplion, and NXP, we can usually find the best fit for a customer's application.
So what about the older technologies? Are they still viable today in this world? I remember back in the mid-90s, there were almost a complete shift in the cellular base station design from the common emitter bipolar devices over to the LDMOS. So do you see a similar shift now with regards to LDMOS to GaN?
So I'll take that question. The answer is yes and no. The RF performance of the modern devices is heads and tails better than the older technologies. But if the customer has a fully qualified design and runs in relatively low numbers, then maybe the improved performance of the new devices does not justify a complete redesign and requalification if the old design is still good enough. We here at RFMW are still sourcing devices that were first introduced to the market back in the mid-70s. And our job is to help clients find reputable current manufacturers for most end-of-life devices. It's just a matter of knowing what the customer needs and having the knowledge and connections to know what's available out there in the marketplace right now.
So how do you see the speed of new technology adoption?
That very much depends on the market. In terms of adoption of the new technologies, cellular base stations stand out. The communications standards involved there require the PAs to be highly linear, often with some DPD, IPAR signals. And you have, of course, the operators demanding very low cost and high efficiency. And some of those are very difficult challenges. The market pull has been very strong. It's not just my kids streaming videos and running up my AT&T bill. It's now Internet of Things, industrial applications, safety critical applications coming through in 5G. So over the last 20 years I've been involved, LDMOS really rose to the challenge, and it's still going very strong. You know, in that time, in that 20 years, we've seen feed-forward amplifiers that were starting off, going back to what you were saying, starting off, they were 8% efficient at the time I worked at PowerWave, multi-carrier power amplifiers. And we had bragging rights on 8% efficiency. Today we have DOTI amplifiers with 50% efficiency. We've seen rapid changes in packaging technologies, rapid changes in integration. We're now starting to see DOTI integrated into a single package. And we've seen over that time, over that 20 years, the amplifiers start to climb up the tower right to the top. So the PA is up in the tower in a more difficult environment. We're now seeing multiple PAs and MIMO systems in the tower as well. So all that takes us on to 5G now, and we're seeing spectrum allocation above band 1 and band 3, which are the only two I can ever remember without a crib sheet. And it's time for GaN. GaN has got a good play now in these higher frequencies above 2.7 gigs. So with GaN, we're seeing more suppliers. We're very strong with Qorvo as our top GaN supplier. We're seeing the Open RAN concept really driving down the price of base stations into commodity aspects, more designers, lower tier designers as well, not just the big guys. And this continued pressure on cost reduction with 5G. So it's going to be very, very interesting, and a continued rapid adoption of new technologies as we go forward. As an ex-LDMOS guy, I'm not predicting the demise of LDMOS like you did with bipolar just then. There's a very good battleground at S-band. You know, the LDMOS versus GaN argument will come on, and many people believe that GaN will be the dominant technology in the future. But we see suppliers edging their bets. Some are supplying both. Cost is still very key. And I think the market is big enough. It's well over $1 billion now, probably in towards 2 billion, some people say. So there's room for both. And I think we're going to need both in this industry for at least for the medium term. So I also wanted to talk about less agile areas that are very important areas to RFMW, but maybe slower on the uptake. We still supply VDMOS today. We get requested bipolar amplifiers today. We have commercial avionics, for example. It can take them 3 to 5 years to design a system and get it qualified. In that time, LDMOS suppliers have moved on 3 generations. And so this can be a difficulty. And RFMW specializes in supporting our customers right through the production cycle and extending those life cycles as long as we can. CO2 lasers is another example of very slow take-up of technology. They love their VDMOS technology, but it's such a big, lucrative market. The LDMOS suppliers have now brought out a 65 volts ruggedized LDMOS technology, which is really good for CW, low frequency applications, and we're doing very well with that technology. So I also wanted to consider the aerospace and defense market. That is one area that's really driven the GaN very well. Again, with COVO, we're covering SATCOM, electronics warfare, radar, from anything from C-band up to Ka band that other technologies really can't touch. So GaN's really become dominant in the aerospace and defense field. But I guess the message is, whatever, however fast you move, and whether it's fast or slow, we have the technologies, and RFMW is well positioned to support all applications for RF power.
We've been talking solely about active devices so far, and of course, RF systems use more than active devices. I assume RFMW supports those areas too.
Absolutely, yes. You have the sort of RF power team around this virtual table, but we also support passives and filters. We support all sorts of small signal RF signal processing and RF interconnect. And in each of those areas, we have a team of experts and can support. So I recently took on a more sort of wider field sales role within RFMW. So my job is to sell a solution and not just power amplifiers. So where there's a power amplifiers, there's small signal, there are filters. We're very strong in filters of just about every type. So we supply crystals, connectors, the whole thing. So I'm supported by a very strong team. So Joel's probably the best person to talk about that strategy, but our job in the field is really to connect customers with suppliers, be a conduit, build those relationships, and provide a full solution.
So talking about all those products together, what makes RFMW different from other RF distributors?
Well, Pat, quite simply, it's our people. We only hire knowledgeable RF and microwave sales and marketing people. We're not distracted by non-RF applications. RFMW's strategy has always been based on people and product, the right people selling only RF and microwave components. It's also the companies that we represent. We only distribute for the best niche RF suppliers on our line card. And lastly, it's our strategically profiled inventory. If you want a product with quick delivery, we typically have it in stock for the more popular RF components.
Well, that's a good answer. Let's see how well you do with this question. What is your prediction for the future of RF?
As we've discussed, I see higher levels of integration in both active and passive components, higher frequencies of operation with a greater number of tier 2 RF manufacturers breaking into different market niches. This is especially true when looking at the future for 5G and massive MIMO. There, the Open RAN and Open RF standards will improve the time to market for both new and established suppliers and allow them to differentiate via new design approaches, as well as standard building blocks and/or software-driven solutions. Overall, I see continued steady growth as the population clamors for new and improved connectivity everywhere. And through it all, we expect that RFMW will be there to support our customers in succeeding in their design requirements.
Yes, the outlook for the RF microwave industry seems very positive, with the continuing demand for connectivity, the advancement of technology, and the key role our industry plays really in the center of it all. And with that, we'll wrap up this special edition of Frequency Matters. Thank you, Joel, Tim, Leonard, and Phil for talking with us today, and to RFMW for putting this team together. And thanks to our viewers for watching Frequency Matters.